Hello guys, welcome. In today's video, I'm going to share a few tips with you when it comes to PCB design. The greatest tip of this video is go watch Philip Salmoni's channel, Phil's Lab. He does a lot of interesting projects and he's very good at explaining things. I highly recommend that you go watch his channel if you want to get into PCB design, whether you're going to use, like me here, KiCad or KiCad, whatever you want to call it, or even, Altium Designer or some other CAD. But he's really good at explaining the basics of PCB design, the best practice, all those things. So yeah, definitely you should check out what he does. Here I'm using, as I said, KiCad or KiCad, I don't know, version 7. And when I installed, so here is the schematic of my custom microcontroller. As you may have seen in my all my videos, I was using an Arduino, but the Arduino was just to observe the signals because Arduino are extremely robust boards. I know that I can throw even 8 volts on that. I'm not gonna destroy the board. But if I do that with an STM32, when I go just above the 3.3 volt threshold, I'm definitely gonna damage a few things. I'm talking by experience. But the entire project really revolves around an STM32, and you're gonna see that when I'll start the software videos. So here is my custom board. Now the first issue that I had when I started using KiCad, at least this version of KiCad, here's how it looked like. It was like that. So at the beginning, I really thought maybe something went wrong during the installation, or maybe there's some library that's missing. I don't know. So I reinstalled the software again and I still had that. I was thinking about changing, maybe downgrading using version 6 of KiCad or using a completely different CAD software. And I started looking for, things on the internet, how I can solve that. And that's even very difficult to formulate. I didn't even know. I was like, my screen is blurry. I didn't know how to type. I went on the KiCad forum. I didn't find anything. And I was just, wandering on the internet like that until I found something. It was not even that obvious. It was a little hidden here and there on some uh, Reddit or I don't know what. And then I found this thing where they just say, okay, you go in preference and you uncheck this, you choose this one, and here you have it. Look at how clear it becomes. And you also do the same thing on the PCB layout part because it's the same. Now, maybe I don't know if it's related to my to the characteristics of my computer. I have a Nitro 5 with an NVIDIA graphic card. I don't know if it's related to that or what, but whenever this option is checked, I have this issue. So if you're in the same situation or you're about to start your, using making PCBs or probably maybe use KiCad, you may consider if you have this kind of problem, just do what I did by checking the right box. So another thing I wanted to talk also about is the connectors that you will use on your PCB. Here is a 3D view of this was one of the first PCBs that I've designed. So avoid using these connectors, these pin headers like this. If you don't have something like a G tag, the G tag, the DB8, DB9 connectors with the flexible ribbon cable, because if you're planning on using Dupont wires on your final PCB, you'll have a lot of issues because they come off really easily. They don't have this kind of secure, uh, the position is not secured like when you're using a GST connector, for example. And the cables, also the Dupont wires specifically, can be extremely stiff. And stiffness is a huge problem when it comes to mounting a PCB into some enclosure. Here is one version of my EMG PCB. And as you can see, I've learned from my mistakes and I'm using the GST connector. Here, the pin headers that are here are just to change the configuration of the board with jumper caps. One of the questions that I also had when I started was the package for my SMD components. Can I use anything like, obviously, one of the constraints is space on your PCB, if you have space constraints. But besides that, can you choose any package for any situation? And no, especially with resistors. Like, it really depends on the power rating of the resistor. So if you see the formula of power equals voltage and intensity, I like to express everything with voltage because it's easier to say, okay, I have 3 volts on this or 5 volts rather than using 0.08 amperes or whatever. It's definitely easier because the voltage is constant and, it's easier to deal with voltage than intensity. So here I just express things and it allows me, given the resistor value and its power, I can determine how much voltage it can withstand. And usually the 0805 is really, it's a classic, it's gonna work well for a lot of electronic devices. So yeah, it's usually safe to just use those one. But if you have space constraints and you need something that's smaller than that, you may consider using this formula to just make sure that the components will be able to withstand the voltage you're planning to use. For the capacitors, you have to just look at the characteristics. I'm going to talk about misconception that I had when I started uh, designing PCBs. I really thought ordering was going to be the easiest part, and no, there is no easy part in the whole process. Whether it's designing the PCB, doing the simulation, the testing on the breadboard, routing the PCB, even until the very final moment when you're gonna order the components you want for the PCB, whether you want the components to be assembled by the manufacturer or do it yourself, you run onto some issues. And I highly recommend that you check first that the components you want for your PCB are available before even starting routing, because it can be really frustrating to go there and start looking for the components and see that you have a shortage. Avoid using fancy values, for example 50 kilo ohm resistors. That's a little bit, you know I don't even know if it exists. Maybe it does exist somewhere, but you rather use two 100 kilo ohm resistors in parallel. By doing that, you're sure that you're always going to find your 100K. That's a classic. So you always have that. Or if you have some special components like, I don't know, your instrumentation amplifier or your comparators, these kind of things, make sure that the components are available first before designing the PCB, and it will really make your life so much easier because you may end up in a situation where you have to reroute everything all over again, and that's not a very pleasant experience. And still talking about that, finding the components is not easy as well. For example, for these screw connectors, when I was looking for them, I typed Phoenix contact. I didn't have any result. I typed screw terminals. I didn't have the result I wanted. I used different things, but I knew that it was there. But I had to type screw connectors. That's when I had what I wanted. So, you know, when you're going on those websites to choose your components, the database is so big that even with the most advanced algorithm, they really need you to help them out a little bit. So it's not going to be always automatic that when you type the name of the footprints, it's going to pop up automatically. You may have to do some, research, find another way of calling your component so that it's going to come out. And yeah, that part can take a lot of time. But once you make sure that all the components that you want for your PCB are available, you can start routing the PCB. Now, talking about the footprints of the component, you may also find yourself in a situation where in your CAD design software you don't have the footprint that you want. Like for example, for this jack socket, I didn't want to everything that was available on KiCad. I couldn't find that on the manufacturer's website. So they had this one and other kind of jack socket. So what I did, I just went on the internet and I found this one on GitHub, the footprint of this on GitHub, and I just imported that on here in KiCad. And that's a 3D model also that I imported from GrabCAD. So originally you just have the footprint without the 3D model here. So yeah, you may sometimes have to make your own footprints or find other ways of still using the footprint. For example, this is the version of the board where I'm not using an instrumentation amplifier, but I have another version where I have an AD8223. And in KiCad, I don't have a footprint for the AD8223, but I have the footprint of the AD620. So what I did is I just used the footprint because it's exactly the same size, the same pin configuration. It's exactly the same. So I didn't really bother myself making something that already exists. Like the footprint is exactly the same. So I just used that. And in my bill of material and component placement file, I just changed the name to AD8223. So I didn't have to make a custom footprint. But those are just little things like that you can do to avoid adding more work to the actual project. I hope that these few tips were somewhat useful to you. Starting from the next video, we'll dive into the wonderful world of embedded software. So see you next time and stay tuned.